2.1c. The learning outcomes is define and write the thermochemical equation for each enthalpy below: formation, combustion, atomization, neutralization, hydration, solution or dissolution. Emphasize on the phase of the components involved. Thermochemical equation. The thermochemical equations show the reactants and products in their correct physical state at the conditions specified and the associated enthalpy change. Stoichiometry of thermochemical equations. First, the sign, positive or negative. For example, 2H2O liquid produce 2H2 gas plus O2 gas. Delta H is equal to positive 572 kJ. The reaction is endothermic. And 2H2 gas plus O2 produce 2H2O liquid. Delta H is negative 572 kJ. The reaction is exothermic. Okay, number 2, magnitude. Consider the stoichiometrical relationship. 2H2 gas plus O2 gas produce 2H2O liquid. Delta H is equal to negative 572 kJ. H2 gas plus half O2 gas produce H2O liquid. Delta H become negative 286 kJ. Since the equation is divided by 2, automatically the value of enthalpy also must divide by 2. Look at this situation. H2O solid change to H2O liquid is endothermic reaction in which delta H is positive 6.01 kJ per mole. 1 mole of H2O liquid is formed from 1 mole of H2O solid at 0 degrees C and delta H is positive 6.01 kJ per mole. H2O liquid change to H2O solid. Delta H is negative 6.01 kJ per mole. The reaction is exothermic reaction. It shows that when 1 mole of H2O solid is formed from 1 mole of H2O liquid, the magnitude of delta H remains the same, but with the opposite signs of it. Positive for endothermic and negative for exothermic. Types of enthalpies. We have enthalpy of formation, enthalpy of combustion, enthalpy of atomization, enthalpy of neutralization, enthalpy of hydration, and enthalpy of solution or dissolution. Enthalpy of formation. Symbol is delta HF. It is defined as the heat change when 1 mole of compound is formed from its elements in their stable states under a stated temperature and pressure. Example, H2 gas plus half O2 gas produce H2O gas. Delta HF equal to negative 241.8 kJ per mole. The heat change when 1 mole of compound is referred to the H2O. From its element is H2 and O2. Make sure compound is 1 mole. Standard enthalpy of formation delta H naught F. The heat change when 1 mole of a compound is formed from its elements under standard condition, which 1 atm and 298 Kelvin. Example, H2 gas plus half O2 gas produce H2O liquid. Delta H naught formation equal to negative 285.8 kJ per mole. When we use the words heat change, means the heat can be absorbed or released. The standard enthalpy of formation of any element in its most stable state form is 0. Example, delta H0 oxygen gas O2 is equal to 0, delta H0 Cl2 0, delta H0 formation and a solid 0. Enthalpies of formation can be used to calculate the enthalpy of reactions by using formula delta H equal to sum of delta H0 formation products minus sum of delta H0 formation of reactions. Look at third example. Given delta H0 formation glucose negative 1258 kJ per mole, delta H0 formation carbon dioxide negative 392 kJ per mole, and delta H0 formation H2O negative 286 kJ per mole. Using the data given above, calculate the enthalpy of the following reaction at standard condition. C6H12O6 plus 6O2 produce 6CO2 plus 6H2O liquid. Okay, solution. By using formula delta H equal to sum of delta H0 formation products minus sum of delta H0 formation of reactants. So, products we have carbon dioxide and H2O. Reactants we have glucose, means 6 times negative 392 plus 6 times negative 286 minus negative 1258. Delta H0 formation of oxygen is equal to 0. So, final answer is negative 2810 kilojoule. Enthalpy of combustion delta Hc, heat release when 1 mole of substance is burned completely in excess oxygen at their stated states. C solid plus O2 gas produce carbon dioxide gas, delta Hc equal to negative 393 kJ per mole. Standard enthalpy of combustion delta H0C, heat release when 1 mole of substance is burned completely in excess oxygen under standard conditions 1 atm and 298 Kelvin. The heat release means enthalpy of combustion involve exothermic reaction. For example, C3H8 plus 5O2 produce carbon dioxide plus 4H2O, delta H0 combustion C negative 2220 kJ per mole. Delta H value is always negative because combustion is at exothermic. Enthalpy of atomization delta HA, heat absorbed when 1 mole of gaseous atom is formed from its element at their stated states. Delta HA is always positive because it involves only breaking of bonds, and a solid and a gas. Half Cl2 gas to Cl gas, so the value is positive. Standard enthalpy of atomization delta H0A, the heat absorbed when 1 mole of gaseous atom is formed from its element under standard conditions 1 atm and 298 Kelvin. Enthalpy of neutralization delta Hn, heat release when 1 mole of water H2O is formed from the neutralization of acid and base at their stated states. Example, HCl aqueous plus NaOH aqueous produce NaCl aqueous plus 1 mole of H2O liquid. delta Hn equal to negative 57.3 kJ per mole. Standard enthalpy of neutralization delta H0 n. Heat release when 1 mole of water H2O is formed from the neutralization of acid and base under standard condition. Standard condition is 1 atm and 298 Kelvin. You have to specify the value of standard condition. Enthalpy of hydration delta H HYD. The heat release when 1 mole of gaseous ion is hydrated in water. Na plus gas change to Na plus aqueous. Since the enthalpy of hydration is heat release, so the value of enthalpy is negative 406 kJ per mole. Cl minus gas change to Cl minus aqueous. Delta H hydration equal to negative 363 kJ per mole. Enthalpy of solution delta H SOLN. The heat change when 1 mole of substance is dissolved in excess water to form a very dilute solution. KCl solid change to K plus aqueous plus Cl minus aqueous. Delta H solution positive 690 kJ per mole. This is exercise to enhance your knowledge about this subtopic. Exercise 1. Name type of enthalpy change for the following reactions and predict whether the reactions endothermic or exothermic. Exercise 2. The combustion of a sample of aluminium produces 0.250 mole of aluminium oxide and release 419 kJ of heat at standard conditions. Al solid plus 3/4 O2 gas produce half Al2O3 solid. Calculate the standard enthalpy of combustion of aluminium and determine the enthalpy of formation of Al2O3 and write its thermochemical equation. So please answer all the exercise.